All right, 7.3, rhombuses, rectangles, and squares. Each one of these is technically a parallelogram. Okay, so when you think about um, a rectangle and a square and a rhombus, each one of these meets the requirement to be a parallelogram. They're just a more specialized kind. Okay, so we said the rules for being a parallelogram were something to the effect of, let's see if I can get this up here. So a parallelogram looks kind of like this. And we said that the opposite sides had to be congruent, opposite angles had to be congruent, and there are some other rules, okay? But if I take this parallelogram and I squish it down, it becomes a rhombus. If I turn it into a 90-degree angle, it becomes a rectangle. And if I squish it down even further, it becomes a square. So a rhombus, a rectangle, and a square, they're all different kinds of parallelograms. So for our purposes today, we'll talk about a rhombus. A rhombus is just a parallelogram that has been squished down until all four sides are congruent. Okay. We'll be tested on this, so make sure you know what a rhombus is. Now, each rhombus has some pretty cool special characteristics. We talked about how on a parallelogram, the diagonals bisect each other. Well, on a rhombus, the diagonals also are perpendicular. So all the previous rules apply. They also bisect, but we're adding more information, wherein they bisect each other and they create 90-degree angles. So that's kind of a cool new information about rhombi. Okay, so a parallelogram is a rhombus if and only if each diagonal bisects the pair of opposite sides. So that means that all the other previous information was true, but now we're adding information in that these two angles here, these two angles are bisected. We're just going to go with that for now. The opposite angles are bisected. This pen, man, I tell you. All right, both sets of opposite angles are bisected. Right here and right here. That's what it means. We know that. If I tell you it's a rhombus, then you should be able to know that the opposite angles are now being bisected. All right. More information about rhombi. All right, so for a rectangle, this is a special kind of parallelogram where all the angles are 90 degrees. Notice the opposite sides are still congruent, both ways, and the opposite angles are also congruent. We just add more information to it. So on a rectangle, the diagonals actually are congruent. Okay? Not only do they bisect each other and all that, but we also know that their diagonals are congruent. All right, so for a square, the additional information we get, a square is kind of interesting. A square is a rhombus and it's a parallelogram. And it's a rectangle. It's kind of all of the above. So when we talk about if this white page here were all parallelograms, we'd have a little, these are the rules that we would have. Opposite sides are parallel and congruent, and opposite angles are congruent. We'd also have the diagonals bisect each other, and consecutive angles are supplementary. That's for all parallelograms, okay? But now, for rectangles, we add in the information that the diagonals are congruent. Then we include in there a rhombus over here has its own special set of rules. You know, the diagonals are perpendicular, okay? That was one of the additional rules we had for a rhombus. And yeah, I think that was it. I can't remember now. What were the other rules for rhombus? We had perpendicular. Oh, and the bisecting. And it also bisects the other angles. Okay? So that would be a rhombus. Now, the square lies in the middle. All of those additional rules apply. The diagonals are equal, and they bisect, and they're perpendicular. So these are the corollaries that you need to know. A rhombus corollary is a quadrilateral is a rhombus if and only if it has four congruent sides. That's what it means to be a rhombus. Rectangle. It's if and only if it has four right angles. A square is both. It has to have a rectangle and a rhombus. If it has all sides equal and 90 degrees, that's what it means to be a square. All right, so if I use all the information that I know, I'm looking for this diagonal here, HK. I tell you it's a square, okay? So I use some information. I say, well, if it's a square, then the diagonals are equal. So I know that HK is congruent to GJ. Well, I also know that the diagonals bisect each other because it's a parallelogram. So I know that GL is the same length as LG. So since the diagonals bisect each other, I can put that there. So that means that the whole thing is just 2 root 2. And since GJ is equal to HK, I know that they're equal to each other. All right. Transitive property right there. So we use the diagonals bisect, and we use the fact that the diagonals are congruent to solve this problem. Now it says find the measure of KLJ. Okay, so I got K here, L's here, and J's here. I'm looking for the question mark angle right here. Well, if I look at it as a rhombus, I know it's a square, but it's also a rhombus. And I know that the diagonals of a rhombus are perpendicular. So I know that the diagonals form 90-degree angles. So I know that this angle is 90 degrees. Okay. Now, if I'm looking for HJG, here's H, here's J, and here's G. This is the angle I'm looking for right here. Now, if I look at this as a rhombus, I know that it bisects opposite vertices. So I know that these two angles here have to be equal to each other. And when I get that, I also know that a square is a rectangle, so it has to have 90 degrees. So I know that this whole angle here, HJK, is 90 degrees. I know that much. It's a square. I know that the outer angle is 90 degrees. But now I know I'm also cutting it in half with the diagonal. So I know that it's 45 degrees. Problem solved. Now it says find the perimeter. Ooh, the perimeter of this red triangle. Well, I know that these two are root 2. And I know that this up here is 2, so I bring it down and I say this is 2 and this is also 2 because it's a square. Now I add them all up and I get 2 plus 2 plus 2 root 2. And I end up with 4 plus 2 root 2. That's my perimeter. I can't go any easier than that. Okay, this is called, you can't combine unlike terms. This has a square root in it and this one doesn't, so we leave them apart. It's just 4 plus 2 root 2. Okay, there's your example 7.19, all the parts and pieces. Going to help you with a lot of those examples. Essential question. What are the properties of parallelograms that are equilateral? That's a rhombus and a square. So think of all the additional rules that we talked about for a rhombus and a square. Okay? For a rhombus, we talked about it being here. So the diagonals bisect each other. Well, we know that's a parallelogram, right? The additional rules we have are that they form parallel lines, or sorry, perpendicular lines. 90 degrees here and here. We also discussed that they bisect the angles. Okay? So there's some more rules that you get just from being a rhombus. Now, if it's a square, we also know what? We know the diagonals are congruent. We know that it's perpendicular, and we know it bisects. Okay? So those 3 pieces of information are something you should know. So if we go on to the next essential question, it says, what are properties of parallelograms that are equiangular? Okay? Now, equiangular guarantees us that it's at least a rectangle. And rectangles, we know that their diagonals are congruent. So we might say diags are congruent. Now, if it's a square, we've got all that extra information. So we could also say that we've got diagonals are congruent, they're perpendicular, they bisect. But that's if it's both, okay? If it's just equilateral, then it's a rhombus. We know a rhombus does 90 degrees, and angles. Now, if it's equiangular, it's at least a rectangle. We know the diagonals are congruent. With this quickly. All right, so there you go. Summarize what you learned in this section. Okay, let's talk about what else is going on here. You know enough to do the following problems from your review worksheet, page 32. You can do all those about parallelograms, rectangles, rhombuses, and squares. You also know enough to do the additional practice problems on 28. You also can start working on the additional example problems. The activity. Okay, so calendar, we're doing 7-3. This is Wednesday. We just did that. Now tomorrow we're doing trapezoids and kites. All right, and then Saturday come in and see Ms. Kerfman if you want extra help. Next chapter you're going to need a ruler. I'll try and provide as many as I can, but bring your own if you want to bring your own. All right, now the multi-step activity on page 14. Okay, these are the rules that you might want to know about this information. Midpoint creates two equal congruent segments. Parallelograms have opposite sides and opposite angles, and diagonals bisect each other. Isosceles right is a 45, 45, 90. That's a special triangle. You may need that. All right, so these are all the information you need to fulfill that multi-step activity. It's a really cool activity. If you weren't in class when we did it in class, I strongly urge you come in after class. We can work on it together. It's a lot of fun. Okay, and that's it. We're done.